Hey everyone, my name is Aaron Brown, and today I'm going to go through a technical walkthrough over the next roughly about 10 minutes on what Cyber-AutoAgent is and how to configure and deploy the agent within your local environment. So, for those that aren't aware, Cyber-AutoAgent is an AI agent for autonomous cyber operation that can perform a range of use cases, from CTFs to web application pentests, that's what emulation and more. For the purposes of this video, I'll assume you have look through some of the blog posts or potentially some of the documentation. If not, that's all right. We have links to docs here in the open source code base that talks a little about the architecture. If you want to learn more about the benchmarks and frameworks, we have them within discussions. And if you want to dive deeper into the community, we have a Discord here as well where you can jump on board a server and learn about some of the upcoming features, roadmap, testing, and share with others in the community. So without further ado, let's go ahead and clone down the application and go ahead and get started. So first, we're going to go take the application here. We're going to go ahead and clone it down to our local environment. I'm now going to pivot over to VS Code. I've already cloned down the application, and now we are going to go ahead and navigate to the actual interface directory for our application. So Cyber-AutoAgent has a couple different modes you can execute with. You could execute directly with Python and arg parsers. You could execute directly via Docker, or we have a new dev application that's still a little bit in development, so it isn't been published to NPM just yet, though we do have it available in the project repo, and more updates are coming to it. But to navigate to it for today's purposes, we're going to go and navigate to the source, to the modules, interfaces, and React. In here, a prerequisite for using this application is going to be having both Docker Desktop and NPM pre-installed. Separate videos can go through and show you how to do that. But assuming that's already pre-installed, we're going to go ahead and type npm install to install the base npm packages for React Inc. and other modules. Once that's done, we're then going to go ahead and make a build. So we're going to type npm run build. This will build locally the application within our workspace. Once that is done, we're then going to go ahead and now start the application. I'm going to go ahead and type npm start, and we're going to now see we have an interface into our application. Now, with this interface, upon first usage, you're going to come up with the setup screen. The setup screen is enabling you to identify which setup mode you want to enable and run your agent in. So I already have mine set up, but you will first have the opportunity to kind of select which mode you want to do. Local CLI is for running the agent locally on the execution environment where the agent is running purely in Python and not isolated. Single container is allowing the agent to execute solely within an isolated container itself, and that single container is a Kali Linux image with about 52 pre-built tools, totaling around roughly 15 gigabytes in size. The enterprise or full stack solution here will effectively install observability and evaluation, so you can monitor traces, you can deep dive into auto evaluation of those traces. It's effectively more containers and a larger footprint from an infrastructure perspective. I have the resources to do that locally, so I'm going to go ahead and select enterprise stack. Now, this instantly configured for me since I already have these images pre-installed and the container running. As we can see here, we have our images and we have our container. For those that are just starting and going through the process, this should take roughly about 5 to 10 minutes, again, depending on your network speeds for pulling down some of the base images and installing some of the base packages. Now that we have an execution environment set up, and we can see that noted here in the bottom left where it says our execution environment, we're now going to go to our config editor by typing /config, and by doing that we can view and edit our configuration for our application. So with that said, now we can go ahead and press enter and open up the model and credentials. This is where we can now press enter again, and we can see a mixture of different providers, from AWS Bedrock, where we have some of the best models, from Anthropic, along with our Amazon Nova series of models, along with Ollama for local models, and LightLLM to access other providers as well. You can see, and you press escape to exit one step back. You can see how we have adjustments we can do for our different model IDs depending on the primary Cyber-AutoAgent model, the embedding model we're using for memories, evaluation, swarm, etc. For authentication, I'm right now using a AWS Bedrock API key, though again, auth is dependent on your provider and the best means that you have access to configure to that securely. You can also adjust other parameters as well down below, and they are a little provider dependent. You can also adjust the operations. This is where you can allow how many steps and iterations you want the agent to perform within its autonomous execution loop. This is again dependent a little bit on your model, your cost, your budget, and really your objective you're trying to perform. I have mine set to around 15. You can also enable or disable the auto-approving of tools depending on how much human in the loop you want access to. And then within memory as well, you can decide, do you want a local memory store or do you want to connect to, for instance, the Mem0 platform or OpenSearch? The same goes as well for observability. If you want to enable remote observability, if you don't, if you have a different Langfuse remote host or prompt management, etc. Same with evaluation and a few other parameters like pricing and outputs. Now that we have that done, I'm going to press Control S and I'm going to save this configuration. This will save to effectively a JSON file stored locally that will securely store our configurations. I'm going to press Escape once and then one more time again to return back to the main application screen. All right, now that we have an execution environment that we are expecting with full stack and we have a configuration we've configured, we're now ready to actually get ready to do the final stages of configuration of the target. Now this will first come into using what plugin we want to define for this operation. Now again, Cyber-AutoAgent supports a variety of different security use cases and objectives. The core thesis behind this is that the agent is being curtailed prior to execution of the use case to a specific end state goal. At the end of the day, this is a goal completion agent. And while CTF and web app might be similar, the end state objective and completion are different. And this is where we can identify and we can press the up arrow or down arrow and select the specific plugin that we want to utilize. In this instance, we'll use a generalized web application pentest. Here, we'll go ahead and press enter, and then we can of course see that that's been loaded here on the left-hand side. Now we're going to go ahead and define a target. A target is what we want the agent to go after as the goal. We're going to go use a purposely public authorized test target that's a vulnerable PHP application. The target itself does not necessarily need to be a web app. It could be a local folder if you're doing code security. It could be a range, etc. It is really a parameter that the user can type in. And once that's done, we press enter. And then we can go ahead and type execute. Execute is really the keynote to initiate the operation. And at this point, we have the ability to optionally provide an objective. We could go ahead and press enter at this point, or we can provide a specific scope or description of what we want the agent to perform as an additional context. For instance, we could say only exploits SQL vulnerabilities in the target, for instance. Again, this is just for demo purposes. We can go ahead and press enter at this point. We can see a security authorization warning about. This is just to make sure that we have explicit approval or that this is an authorized target. Again, this is for training purposes, and this is a purposely vulnerable website. We're going to go ahead and press Y twice to acknowledge and to continue. What's going to happen next is the agent is actually going to get started up and initialized. Since we're in full stack mode, these commands are now being sent over to our Docker container to initialize the agent. This is going to be first locally on our client and setting up a folder structure that you'll here now see popped up called outputs. You'll see a list of that the target is, and now you'll start to see what's known as memory. Memory is that memory that we defined earlier, since this is local memory that's stored here, and we can see those files are stored locally. We can also then see the operations as the stream is now beginning to come out. We can see since this is the first step is to reason, the agent will first discern what is the goal and objective here. What do I need to complete? And it will always first either look at, has this an operation that has been conducted against this target before? If so, It will then list objectives and go ahead and create a plan. If not, it will go ahead and then start to generate a plan. Here we can see it started to make a plan. We can see the different phases in that plan. We can see the tools that it called in this. We can then see at every step in this stream, the tools invoked, the output, the reasoning between that step, and that will continue on. We can also then start to see our footer metrics in terms of token usage, cost, duration, and an escape key as a kill switch if needed. You'll then also start to see over the course of the assessment different parameters in this folder structure begin to populate for different artifacts, tools, and the execution prompt that is being prompt optimized over the course of the trajectory of the agent. I'm going to go ahead and kill this for right now, just because, again, for demo purposes. What you will see at the end of this in this operation here is a final report. And this final report will be a markdown format for any plugin, and this will show you exactly what the agent did during its operation. This is generated based on the memories defined by the agent. It will give you a description, what the agent performed visually in terms of what was actually done, what were the findings, what was the attack path. We'll also see stored local artifacts of what was done, etc. So proof of what was done to help mitigate the chance of any potential hallucinations. And this will be a pretty in-depth report. For purposes of time, I won't go too deep there. I'm just going to lastly showcase everything that you've seen so far in full stack mode. Can also be seen in terms of Langfuse if you have that enabled. In order to do that, if with the base configuration, you just will navigate to the local host. Port 3000 is the base configuration. Once you do that, then you'll be able to authenticate with the default credentials provided. And once that's done, you'll be able to see all of the traces, model costs, some of the automated scoring we have behind the scenes for each of the traces in that trajectory. You can see how that's changed over time, cost usage, consumption, and different dashboard metrics around latency, etc. If you want to dive deeper into each of the traces themselves, they'll begin to populate and load in this screen here. And this is, again, how you can dive and do evaluation to see what the agent actually did and performed over the course of its trajectory. This was a short run we just did and we canceled. But here we can see, we can view the graphical representation of this agent. We can view that over time. And we can see even more complex agents. For instance, here, this one went for a little bit longer here. And we can see the spans and parent-child relations between each tool and each invocation, how long they went, what the cost structure was, what the tool name was. We can then even see metadata associated with each of these as well here. We also have then a prompt feature. This is for prompt iteration and prompt versioning, so we can look at the core system prompts as well that we have defined in this system, make iterations here as well, and adjust them over time. And then lastly, again, we have a scoring feature. So the scores for each of those operations for common frameworks and metrics, for instance, the evidence quality, the methodology adherence, etc., are scored by a critic LLM, that eval LLM, and that's done to help us understand how the efficacy of our agent is performing from a data science perspective. So again, you guys have all just seen a technical walkthrough of Cyber-AutoAgent, an AI agent for autonomous cyber operations. This is the first of many videos to come, and really a first release of this solution at this state. So welcome to feedback, join the Discord, and learn more. Thanks, everyone.